Okay, here we go with a question on pendulums. Those of you who have done any past papers on this will know that pendulums are a very common topic, so make sure you're familiar with them. As ever, please have a watch, and if you've got any questions, let me know. My apologies in advance. My pages have scanned really badly here, so it's going to be a bit jumping about, so my apologies if that's the case. So we're looking at page, let me just get this right, 19. Yes, okay. All right, so as I say, pendulums are very common, but they ask you different things. So firstly, we're told we've got a pendulum. We're going to measure the time t to complete 20 swings. Really good technique and something that you should always do. Okay, I noticed there are questions sometimes which only measure one swing, and that's not okay because that will have reaction time as an error. Okay, we always measure for 20 and then divide by 20. Okay, so we're firstly asked to do some measurements. Now, really important here, they firstly define what the length L is. It's the distance from the bottom of the clamp to the center of the pendulum bob. So you've got your diagram here. You see I've drawn on here. I've drawn a line at the top, a line at the bottom, and a line in the middle. And I want to know the line at the middle. And you can see it goes down to 33.5678. Okay, 33.8. And that's why my answer here is there. The lines here were really just a visual aid for me. You don't have to draw them. However, I think it's really helpful to do this. In a previous question, we talked about finding the diameter of an object, circular object. This is a way of doing it. You put one line at the top, one line at the bottom, and measure the distance between those two lines. So I think that's a really clever technique, one that you can really use in lots of different questions. Okay, that's what I did here. I actually measured this point here, measured this point here, and found the halfway, and that's fine. Okay, this is where I'm saying we're going to skip pages. Sorry, I don't know what's happened here. 18, we should be on page 20. There we go. We'll go back to 21 in a minute. It then says to us, stopwatch shows the time t for 20 swings, and we want to firstly record t to the nearest 0.1 seconds. Okay, so we've got 23.46, nearest 0.1, we're going to round up to 23.5. I'll be honest with you folks, these 1 markers, okay, they are ones which trip people up. So just make sure you know that those are seconds, and then after this, these are your millisecond reading, or sorry, your centiseconds, I should say, 0.46, all right? Just make sure you're aware of that. Check that it's not measuring in minutes there, because that could be slightly different. Now, we're then asked to calculate t for 1 swing. Well, we know that this is the time for 20 swings, so we're going to take our value and divide it by 20. Now, I've taken 23.46, because that was my original number, divided it by 20, and I got 1.17, and I've given it to 3 significant figures. Now, again, some students get really worried about significant figures. Here, I would advise going with 3 because the previous number was at 3 significant figures, and that's kind of why we do these averaging methods to give higher significant figures. I think in the mark schemes they tend to vary in terms of the significant figures that they accept. However, I would just go, if you've used 3 in this one, just use 3 here, and right afterwards 3 significant figures, and that way you're showing you understand that you're presenting your answer to 3SF. Okay, so we've done that. We're going to calculate t squared. Now this time I'm going to take my value from here. I could have taken the 1.173. I'm going to square it, and again I'm going to present it to 3SF, and I've been a bit bad here. I should write 3SF there as well. Again, it's just a case of being consistent. 3, 3, 3. That looks nice to me. Okay, there are complicated rules about significant figures. However, at the GCSE level, you're really not expected to know these, especially not for 0654, perhaps for the standalone sciences. But this is one of those details that we miss out. So don't worry too much about it. We generally tend to stay away from 4 significant figures, or 1, 2, or 3 usually works. All right. Calculate the acceleration. Okay. So you're going to use your answers from the different parts. We're going to use L and T. Okay, now this is where, I'll be honest with you, I got a little bit flummoxed. Okay, because the value of L, which you can't see on the screen just now, was given in centimeters. Now, if you'll notice, your answer is expected to be in meters per second squared. So initially I thought maybe there's expected to be a conversion here. So actually I did that. All right, so I did my calculation, and what I found was that it was a really, really small answer. All right, if you convert your L to centimeters, which you completely reasonably do, you would get a value which is 9.67 times 10 to the minus 3. To the minus 2, which is very, very small. So I then went and recalculated it without converting, and that's what I've written here. 0.395 times 33.8, that's our centimeters, divided by 1.38, that's my t squared, and I got a 9.6746. Now that is very close to the gravity on Earth, 9.81, and so that's reasonable, okay? I think that's a little bit, I can imagine students would convert here because they've seen those units and they would get the wrong answer, okay? I think just take the number that you've been given, don't do anything clever, this is a paper which is not requiring that level of analysis, just put in the value that you got for L. Okay, so that's me overthinking it, my apologies if that's confused, okay? I'm going to come back up now from 20 to 21, sorry, it's all over the place. 21, we've got a student given a ruler A and ruler B, we want to know which ruler they use. Well, we use ruler A, okay, because it has a higher precision, it can measure to 1 millimeter. Notice here, ruler B could only tell us +1 ± half a millimeter, really, right? Half a centimeter. Whereas here, we can measure things to the nearest millimeter, and therefore it's a higher precision. Okay, we tend to stay away from the word accuracy here. Accuracy means it's correct, whereas precision means that it's more. We can measure to a smaller detail. Okay, a student does the experiment and uses a fan to keep cool. Okay, they suggest what someone does to minimize the effect. I'll be honest, I don't think I would have got this mark. The answer is, the acceptable answer, okay, was that you just place a barrier in front of it. We don't adjust the fan. So, a lot of students would say, turn off the fan, turn down the fan, move the fan, adjust the position of the fan, turn the fan so it does not face you, but you're not allowed to say that. You just put a barrier in front of it. And I'll be honest, when I was doing this, I really did struggle to think that up. And I think in an exam, I would have a mind blank and write something like move the fan, okay? I think sometimes these questions are just a bit too obvious, the answer. And when you see them, you go, oh, it makes a lot of sense. But I didn't think of it at the time because you're kind of assuming you want something a bit more scientific, okay? So don't overthink it. Place a barrier in front of the fan. Place a shield in front of the fan. All right. Last one, explain why it's more accurate to time 20 swings. We've talked about this already, okay? My way of answering this is to say it reduces the effect of human reaction time. Put simply, your reaction time is about 0.2 of a second. Now, if I measure one swing, then that will have an uncertainty of 0.2 seconds. However, if I measure 20 swings will have the same uncertainty. Divide that uncertainty by 20, I get a much smaller uncertainty. Okay, now that is, again, going into too much analysis for us, but I wanted to kind of explain it in better terms. For us, we just need to say it reduces the effect. It means that essentially reaction time, the effect of reaction time becomes 20 times smaller. As I've said throughout this question, this is a standard question, lots of things that have come up again and again. Human reaction time, measuring things, and importantly, pendulums. So make sure you know your pendulum questions, people.